Okay, let's apply this to an application here. We'll do a word problem. So Darcy is buying apples and oranges for a large fruit basket to give away as a door prize at a charity event. Apples cost 24 cents each and oranges cost 80 cents each. She has $12 to spend and would like to purchase at least 20 pieces of fruit in total. So write a system of linear inequalities to represent the situation and then graph it. So first of all, we want to write the inequalities. Well, we have to define our variables here, don't we? Duluth, what should we call the variables here?
We could call them X and Y.
Sure, let's just call them X and Y and define which one is which. So X is going to equal what?
The number of apples.
Okay. And Y?
Is the number of oranges.
Okay, good. So what's our system going to look like then of linear inequalities? So tell me one. Let's take this. How about we take this first statement up here. Apples cost 24 cents each and oranges cost 80 cents each, and she has $12 to spend. So what's that going to look like? What do you think, Duluth? Can you come up with an equation to represent that information? Or an inequality, not an equation?
So it would be 0.24x plus 0.8y
Okay.
is less than or equal to 12.
Okay, good. Right, because she only has $12 to spend. She could spend less than $12, but she can't spend more than $12, right? So there's the first inequality. Anybody got another one here? Let's see. Jace, how about you? Give me another one.
Would it just be x plus y is greater than or equal to 20?
There you go. Because she wants to purchase at least 20 pieces of fruit total, right? Okay, so there's those two, right? We'll go ahead and graph this with technology. How about? Okay. So if we're gonna graph this with technology, we're not quite done yet with this. As far as the book was concerned, we're done. But you tell me if we can improve on our system here just a little bit when we graph this thing. Okay, so the first one we had 0.24x plus 0.8y is less than or equal to 12. Okay, and I'm going to make that purple. So there's our first one, right? Second one, we had x plus y is greater than or equal to 20. There it is, right? Okay, so the overlapping region that appears to be this region down here, doesn't it? Everybody see that? Okay, what's wrong with that region? It said, then the second part says, pick a point that represents a solution. Well, any ordered pair that sits in the shaded region would work, right? Including on the boundary lines. Okay. What if I pick, so like the point right here, for example, x equals 20, y equals 5 would work. 20 apples and 5 oranges would be at that point right there, wouldn't it? Right? And that's in the shaded region. Okay, but the way we've got this shaded now, it also tells me that that point should work. What's wrong with that?
You can't buy negative apples.
Yeah, you can't buy a negative number of apples, can you? And you can't have a negative number of oranges either, really. So what other two inequalities could we reasonably add here that probably also should be included? How do we say that you can't buy a negative number of apples?
X has to be greater than 0.
Good. It could equal 0, couldn't it? So we'll do x is greater than or equal to 0. Okay. And then how do we say you can't buy a negative number of oranges?
Y has to be greater than or equal to 0.
There you go. Y is greater than or equal to 0. And if we look at all the intersection of all those things, it looks like the common intersection is that little or that little triangle right in there, isn't it? That's the one that's quadruple shaded. Everybody see that? Okay, so that contains all of the infinite, well, not infinite in this case because they're discrete numbers of the pieces of fruit, right? So that contains all of the possible combinations of apples and oranges that would work. Okay, make sense? Give me a 1 to 5 on that. Okay, good. All right, take a picture of this guy. Okay. And then really this last one, I don't know if we even need to do this. I mean, this is just, we're just going to graph the solution of this system of linear inequalities, and it just has multiple, it has 4 different inequalities. But that's all right. It's just going to give us, potentially, it's going to give us 4 different parts of the boundary. Okay, if I graph this thing. And now it doesn't have to be all 4. Like in the last one, we had a 3-sided shape and we had 4 inequalities. But we could get up to 4 different sides on this region then that's defining the solution, right? Some of them are going to be dashed boundary lines and some of them are going to be solid this time. But do you want to go through this one or not? You tell me. You guys either give me a thumbs up if you want to go through it, thumbs down if you don't, or yes or no in chat. Okay, let's go through this last one. So then what about this? If we want to quickly graph these, I'm going to steal oops. I want to steal a XY plane and we'll just graph that. We'll do this one manually without technology. How about? Okay, so if we graph, first one will be red. We could certainly do the cover-up method on that. We could also, we haven't talked about this yet, we could also just solve this one for y, couldn't we? We get y is less than or equal to negative 2x plus 6. So we could just graph that from slope-intercept form. We've got a y-intercept at 6. We've got a slope triangle of negative 2 over positive 1. And then we would and it's a solid boundary line, right? So we'll just connect and extend. And which way are we shading on this one? Kendall, which way are we shading?
Beneath it.
Beneath it, good. Good. So well, I guess I should continue that line down all the way. We shade down here. You get the idea. So there's the first one. Next one's pretty easy, right? X is greater than or equal to -5. What's that going to look like, Carrie? What's our boundary line?
-5. It's gonna go to the right.
Yeah, okay. So what's the boundary line look like?
Up and down.
Okay, so vertical line, good.
Yeah.
Good. And it's solid, isn't it? Yeah, we're going to shade to the right, aren't we? Because we want the values of X that are greater than, so to the right of. Good, good. So there's second one. What about the third one? Y is less than 2. What's that going to look like, Liliana? What's our boundary line here?
2. You'll go left, right.
So horizontal or vertical?
Horizontal.
Horizontal, there you go. Good. And we're shading below, aren't we? Good. So good. And then finally, we get, what's this going to be? Well, orange, I guess, huh? So X is less than 4. We already did an X. So that's going to be a vertical line at 4, but it's going to be dashed this time, isn't it? So there's our vertical line, and we're shading to the left of that. And so we end up with our doing that, right? And so what's it look like? That's difficult to see there. We got to find the place that's shaded 4 times. So it looks to me like it's going to be, boy, it's kind of hard to see on here, but you guys correct me if I'm wrong on this, but that's going to be the top. We said it had to be below that line, so it looks like that. Is that the boundary? Is that what you got? Give me a thumbs up if I'm doing that right. Okay.
Except that the right side is dotted. Right?
Oh, the right side is dotted. You're right. Yep, I got to fix that. There we go. So that should be, and that's solid. Good. And then that's it. Everybody agree? We got it. Okay, you don't have a ton of time, but you have a little. So I'm going to let you folks work on the assignment that's up. This is the 2.6 practice 2. And that's the last of the regular assignments. And then I'm going to put up today I will put up a review assignment and a practice test. And what do you think here? You guys tell me here. So are we, I feel like, what do you think? When can we test? Do we want to test Wednesday or would you rather test Friday? Would Friday be, I mean, if I almost think Friday probably seems like the best, just because if I give you a review assignment, I want to make sure you can get questions answered on the review assignment, right? So I'll give you a review assignment. You got practice tests to do. That's quite a bit of stuff to do. So why don't we go ahead and just say we're going to test Friday, and then Wednesday we'll have available as a day, and you guys can kind of decide what you want to do. If you want me to go through problems, I can go through problems. What I would recommend for Wednesday, I think the best thing would be for you folks to do the review assignment, as much of it as you can prior to that, and then you could come in with questions, and I could just, I can help people with stuff. I can either pull people into breakout rooms, and we can do it with individuals or small groups, or we can do it as a big group. You guys will decide on Wednesday what you think is going to work best for you based on the review assignment. Okay? Sound good? All right. Have at it. You can start working on the assignment.